This lesson is around using the normal curve in reverse. Sometimes we are required to find the value of z corresponding to a specified probability that falls between values listed in table 8.3, the standard normal probability table. For convenience, we shall always choose the z value corresponding to the tabular probability that comes closest to the specified probability. So you just look for the nearest. You don't need to interpolate. You just look for the nearest value. We're going to go through an example where we reverse the process and begin with a known area or probability, and then we're going to find the z value and then determine x by rearranging the formula. So we're used to now our z is equal to x minus mu divided by sigma, but we're going to be looking for what is the x associated with a given probability. And so we're going to look at this example. Okay, so let's look at this. We have a statewide annual rainfall plus snowfall in one of the U.S. states is normally distributed with a mean of 40 and a standard deviation of 6. So what is the value for x such that the probability that big Z is less than or equal to little z is equal to 0.45, and what is the value for x such that z is greater than or equal to little z is equal to 0.14. We would look at A, would be we're looking for what's the value of x such that the area is to the left is 0.45 because it's less than or equal to little z, and then the probability that z is greater than or equal to z is equal to 0.14. We're looking for what's the value of x at this point that we have 0.14 to the right, because that's greater than or equal to. So let's work on A first. Okay, so we know that we need to follow the equation that x is equal to sigma z plus mu. And we have sigma is 6 and mu is 40, so we need to find what is z. So when we go to the z table, we look for 0.45, and because it reads to the left, we can just use the value nearest to 0.45 on the table. And when we go to the z table, it's at column, it's at row, sorry, negative 0.1, and column 0.03, that we find 0.4483, and that is the closest value to 0.45. So we use that value. So our z is equal to negative 0.13. We grab that right off the table, and we're going to plug that into our equation. So we'll have our x is equal to 6 times negative 0.13 plus 40. And when we do this math, we have our x is equal to 39.22. Okay, for part B, we're looking for the probability that z is greater than little z is 0.14. So at that point, that would be our z value that we want to find that leaves 0.14 to the right of the z line, which means it leaves 86.86 to to the left of the z-line. So we look for, because this z-table is cumulative to the left, we look for 0.86 on the chart. And when we find it, it is actually at row 1.0 and column 0.08. So our z value is 1.08. So we calculate our x by multiplying 6 times, that's our sigma, times our 1.08, that's our z, plus our mu of 40, and we get a value of x is equal to 46.48.